additions, segment additions, all of those properties are dealt with in terms of equality. Things are equal. Segment plus segment equals larger segment. Angle plus angle equals larger angle. But a lot of times in our proofs, they talk about things within congruencies. So what we need to be able to do sometimes is make this little flip switch between equal and congruent. Remember, if things have equal measurement, they're congruent. If things are congruent, they have equal measure. It kind of means the same thing going both ways there. It's a biconditional statement. So, but basically what you're doing here is if you ever have to switch from equal to congruency, all you're doing is writing that out. So let's say you're started with x equals y is a given. X is congruent to y. All you have to do here is this, definition congruent. That's how you make the flip. And it does the same thing going from congruent to equal, if you had to do that way as well. Oops. Does that make sense? By putting them both on there, I can flip between the two. It's a very common thing. Whenever you have statements that you wind up with segment addition or angle addition, or a lot of times when we give you stuff like the example here, number 1, where you had segment equaled 9, something else equaled 9, those two are equal to each other. Anytime you see this thing where it says definition of congruency of segments or definition of congruency angles, watch your shoes. It's saying that reason I abbreviated to just being definition congruent. It just means you're switching signs. You're switching from equal to congruency. That's all. So if we look back at this proof, did everybody have this one here? Okay, sorry, I'll wait a second. You stay up and watch that?
I forgot all about it.
I fell asleep in the 6th.
What did you say?
I thought it was tonight. I was mad when I found it was 6. At least at 1. So. I was watching the Dodgers.
I know. I was so tired. I fell asleep, and I'm a long-suffering Cubs fan, as you well
Yes.
know. And when I saw that they were down by 3 in the 6th inning, and they were just kind of
Gave up.
I kind of was like, you know what? It's 9:30. I'm exhausted. I got a lot going on this week still, and I kind of sat there and watched, and just kind of fell asleep. And my wife turned off the TV then, and then I woke up middle of the night, and I'm like, what happened? I'm like, son of a really? Son of a billy goat, right? So, but whatever. But yeah, it's baseball is just a silly sport, you know. Oh well, Mr. Austin.
My aunt's a White Sox fan, and so,
Guys.
she literally eats goat like meat or goat milk, like some kind of like goat cheese before every game versus the Cubs. And it's just kind of like rub it in against some of her friends.
You know, that's the difference a lot of times between Sox fans and Cubs fans. Sox fans, and this is no offense if you're a Sox fan. If you're a Sox fan, that's fine.
No.
I have no problem with that. I honestly have no problem with that. But Sox fans will do anything they can to show that they're a Sox fan. Seriously.
What if the
But
Sox versus
more,
Cubs?
and this is more of a generalized statement than it is a specific. Most people that I know that are Sox fans will gloat anything they can over a Cubs fan. Cubs fans are like, yeah, whatever.
Just look at the comments on the news feed.
Don't read it.
What would you do if it was Chicago White Sox versus Chicago Cubs?
Oh, I've been a Cub fan my whole life. Anyway, so let's go back to this here real quick. Notice, when you're looking at this proof here, what's nice a lot of times when you have these fill-in-the-blank style proofs, you'll see kind of their progression of ideas of what they're going through. They've gone equal, 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 I don't know, but there's a definition of congruent here. Then all of a sudden it goes congruent, congruent. What do you think they switched? They switched the sign from equal to congruent. So all they did then is just wrote it out as HI is congruent to IJ. Now, the next one is kind of weird, to be honest with you. Myself, I probably would have put this statement earlier, which is how they worded this one through. What is this next statement? It's given. A lot of times the book will throw a given towards the back end of something as opposed to usually up in the front, because remember guys, there's going to be a bunch of different ways to solve and write out proofs. There's so many different ways of doing them. This is just one method. So now look at what they have. They have HI to IJ, IJ to JH, HI to JH. Isn't this on a diagonal? What property has the stuff that has a diagonal? What's that? No. It's the law of syllogism, but it's also called, we have this in our notes. Where was it here? Oh, my up above. Yep. Transitive property. Remember how I had you guys write down on the bottom here by transitive property? Bless you. Remember, basically transitive property works out to be this. If A equals B, B equals C, A equals C. And the rule is transitive. Transitive property is different from substitution because transitive has something on a diagonal, whereas substitution is generally vertical. Okay. So what that one is there is just your transitive property. That's it, and you're done. That's how that one works. So I know that we did not really get into a little bit of the extra bits and pieces to help with these yesterday, and that's okay. I appreciate you guys trying to get through some of them, and that's great. And this is what kind of how we start with a lot of our proof stuff is we take these little bitty baby steps and we go from there. All right. Excuse me. Let's take a look at the second one. See how we did there. What was that? Yeah, the last one would be just transitive property. Second one I think is a little bit easier to follow. Hopefully. So yesterday we talked about complementary angles. According to your progression sheet, what did it say about complementary angles? So if we're given complementary angle, we would say angle plus angle equals 90. Okay? So notice you're given complementary angles. 3 and 2 are complementary. That means it was given. So since it was complementary, according to your progression sheet, the next thing that you should say was, oh, sorry, this second one was also given. But now, 3 and 2 are complementary. Look what they wrote here. What's your reason? Definition of complementary. Right off the bat, you've got that from your progression sheet. You were given complementary, so you say something about it. Now, look what they did the next part. The next part they wrote in 1 plus 2 equals 3 plus 2. Why? Because what's that? Well, we don't know that.
But look at statements 2 and 3, and how do those relate to statement 4?
No. Substitution, very good. Again, notice you have two things that are equal to the same thing. Two things that are equal to the same thing. Last time I checked, 90 equals 90, correct?
I think so.
I think so too. So, what's that? These two things are equal to the same thing, which means they have to be equal to each other. So in order to do that, again, it was substitution. Okay. Now, what did they do to get 1 and 3 equal to each other? They subtracted 2, so what's the property for that? Subprop equal, very good. All right, notice they have angle 2 on both sides. It's an equation. If I subtract it, doesn't it go away? That's what they did. They subtracted the angle 2 from both sides and left with that. They eliminated it. That's how that works. If you have the same thing on both sides of the equal sign, you can subtract it from both sides and it'll go away. Now, what do they do at the end? Very good. Definition of congruent. They switch signs. Okay. Now, one of the things that's weird about the idea of these fill in the blank ones is that it takes a little getting used to what somebody else is thinking. A lot of times, I've always felt that it's easier on you guys to do it on your own, okay, to kind of work through it. So what I want to do is look at this third one and keep going with these. We'll just keep putting these things in. I'm not collecting that because we just did them all. I want you guys to have a good bank of these to start with. So let's write this out as a given and prove statement, and we're not going to look at their statements. We're going to do this on our own and see what we can do. So let's throw this in our notes, and we'll see what we can come up with. Okay. Make sure you have your reason bank out and your progression sheets, so that way we can kind of relate back and forth within those, see how we do. I know. I saw a stat this morning about second baseman runs saved in innings, number of innings. Why is this third on that list? There's only like 280 innings, whereas the other else like 1,400 innings. Guys, it's just stupid. All right, so
Don't call him stupid.
it's just crazy. Yes, sir. Yes, sir. So let's go through this and see what we can come up with. We have a given statement that AL equals SK. We have a diagram. What do you think you should do to your diagram right away? Draw it and let's mark it. We know that those two things are going to be equal. Okay? What it wants us to prove is it wants us to prove that these two are going to be the same. So a lot of times when you start looking at diagrams and marking them up about where you need to go with them, it's going to help you tremendously to get your thought process going about what do I have to do to get there. Okay. Excuse me. So where do you think we should start? With the given. It's a good place to start. Now let's look at what we have. Look at your diagram. The diagram itself is asking us to get from AS to equal LK. What is AS made up of? AL and LS. What is LK made up of? LS and SK. So are they both made up of the same, do they both share a common part? What do they share? They both share LS. So how do we show addition of segments? We're talking about segments here. Why would you say anything about a vertex? Segment addition. How do we talk about addition of segments? Oh, I don't know, segment addition. Try to help you out there a little bit, guys. So what we need to do, excuse me, what we need to do is that we need to, when something isn't given to us, and we're going to talk about segment addition here, we have to define something. We have to say that it exists. Does LS exist in our diagram? Okay. Now, if you look at your reason bank, there's a property in there called reflexive. The reflexive property shows that you are yourself. It's on the front page, I believe. It has reflexive property, A equals A, AB equals AB, angle A equals angle A. That's reflexive property. So what I want to do is put a little note underneath reflexive property. And say, you are yourself. Okay. So, when I go back to my proof then, and do we all agree that we have to add LS to make it AS, and then LS to make it LK? We have to add it to both segments like that? So let's do this. Excuse me. We first, in order to add something that's not given to us, we have to say that it's there, so we have to define it. Yes, sir? What's that? We have to do that. It's not a very common thing that it has to happen, but it is one of the things that will happen from time to time, that you have to define something. This is one of those types of problems that you have to define that there's something in the middle. This happens with segment addition styles, and this will also happen with angle addition. If you have two smaller angles that you have to wind up adding to show that they equal the bigger, if you have to define that middle portion, this happens all the time. Okay? So the property that this works, you are yourself, is reflexive. We okay with that? Okay. Now, if I add together AL and LS, what is it going to equal?
You only need two letters to make a segment.
What property tells you two smaller equal the whole? Segment addition. Oh, you know what? I probably could have done it easier. Let's scratch that. Let's scratch that for 1 second. Let's do this. Let me do something else here real fast. I just realized that I'm going the long way. I just thought, and this happens a lot of times in proof. What if I add the same thing to both sides with an equal sign? What is that? That's add property equal, right? Because we already have AL and SK together. Yeah, I just saw that too, right? Can I do this? Am I adding the same thing to both sides with an equal sign? What properties when you add the same thing to both sides with an equal sign?
Cancel each other out.
No, they're adding. What's that? Not substitution. We're adding the same thing to both sides. It's add prop equal. What is AL plus LS equal? AS equals. What did you do here and here to show that? Added two segments together to get a different segment. Segment addition. I got ahead of myself on that one. A lot of times when you have, and this is a very common thing, if you have a if you have what's gonna look like it's gonna wind up being a segment addition problem or an angle addition problem, you're gonna wind up having to find something in the middle, add it to both sides, and then you're using segment addition or angle addition. It's a very, very common thing. I also kind of think that as we get into more of midpoint stuff, things along using those properties, it's going to be easier to see how these things work.
Would we not need to have that intermediate step of AL plus LS equals AS, and then the LS plus SK equals LK? We don't need that intermediate step with the segment addition to then get to that one? Or
You know, you
I mean,
could.
in my brain, I would want to do that.
Yeah.
Would that be okay if I did that?
Yes.
Okay.
Yeah.
All right.
Because then you set yourself up for substitution,
Right.
and that's just it.
Right.
This works. Too. I mean,
Okay.
I'm okay with this. I mean,
Okay.
I think you're right. It's more technical that way, but
Okay.
trying to make it a little easier.
Okay.
So right now. What was it? Let's do a midpoint. Let's do a midpoint. Right. Thank you. I got that on the truck. Lightens.
Huh? Use it. I'm trying to.
Alright, so where do you start any single proof that you have? With the givens. Okay? So the given here says M is a midpoint of AB. The other given is B is the midpoint of MD. So when I have two givens, and they both have stuff that's on my progression sheet, midpoints, I'm going to write them out separately. Okay? I'm going to write them out separately. So I'm going to start with the first given. First given says M is midpoint AB. Am I going to be really mad at you guys if you forget to put the little bars over the ABs for segments?
Yeah.
No.
Oh, would it be wrong?
No.
Oh,
No.
sorry.
I forget a lot of times. I know that it's supposed to be technical in some parts that have it, some parts not. It's not the end of the world.
Sorry.
Okay, it really isn't. The proof police isn't going to come after you. Yeah, Lockhart's a member. So, according to your progression sheet, what does it say to do when you have a midpoint? What does it say in your sheet? Segment equals segment. Okay. So it tells me that since I have a midpoint, I have to use segment equals segment. So I know I'm going to have to get something equal here. And what's going to be the reason that I do that? No. Look at your progression sheet. I'm using midpoint. It's going to say segment equals segment. What's going to be the reason?
No.
Definition of the midpoint. Okay, so now what I have to do is figure out what two segments are equal to each other. Well, if M is the midpoint of AB, oops, AM has to equal MB. That's what it means. That's what it means to look at a proof with this next to you. Thank you. Whenever you have a proof, guys, and you have this right next to you, you're going to be reading this and going back to here. Well, I have a midpoint. Well, what does the midpoint say to do? Bless you, segment equals segment. Yes, sir?
So that means we could, for number 3, put definition, for NBVD.
We haven't written anything down yet about that. We have to write down a given prior to Ronnie. You're on the right track. Okay? You're on the right track. This is the idea that I keep saying, that proofs are a bit of a pain in the butt. They are. But, the other butt. You have in front of you this sheet of paper that basically tells you everything to do after some sort of a given statement. There shouldn't be any ambiguity of not knowing where to start. Okay? So we've done our definition midpoint. Is there anything else I can say about that first given? No. I go to the second given. The second given says that B is the midpoint of MD. I have another midpoint, which means I'm going to use another midpoint definition. According to my progression sheet, it says, after you have a midpoint, to say what? We have our given, but after we have our midpoint, what do we say? What does it say to do? Segment equals segment. What are going to be the segments that are equal now if B is the midpoint?
MB equals
How many tick marks should I put on BD if MB has one?
1.
One of them. I only have to put one because it already has one. So now my fourth statement is going to be MB is BD. What's the reason? What did we just use? The definition of midpoint. Ladies and gentlemen, this is the whole reason that I give you those sheets, those squares, so that way you can work off of what you have. You're welcome. Yeah. Okay. So, excuse me. Look at what it wants you to prove. It wants you guys to prove that MD is made up of 2 times MB. What is multiplication really? It's repeated addition. Multiplication is adding multiple times. It's repeated addition. So 2 plus 2 plus 2 is 2 times 3, which is 6. That kind of thing. So what they're saying here is this is the same thing as saying MB plus MB. So what I want to do is kind of figure out a way that I can get MD written out. According to our diagram, what is MD made up of? Okay, good. So we know by looking at the diagram that MD is made up of 2 smaller segments. Bless you. How do you write that? Segment equals the sum of 2 smaller segments. What property says segment plus segment is bigger segment? Segment addition. So I can say then that MD is made up of, what was it? MB and BD. And what's the reason again? Larger segments made up of 2 smaller?
Segment addition.
Segment addition. Okay? Oops, I won't get too far ahead of myself here. Remember what it wants you to finish out with. It wants you to finish out that MD is made up of 2 MBs. I have one of them now. But I also have one of these. I can't do the diagonal, but what I can do substitution because I know that it's equal here. See that? I have that already equal to one another, so just like Austin said, I can throw that substitution step. Hey guys, you want a good hint? 80% of the time, when you don't know if it's not a given or a definition off of your progression sheet, it's probably substitution. So if you were the type of person who just likes to guess, substitution is probably a pretty decent guess sometimes. Okay? It usually is. So look what happens. There's your substitution. Now this next step I don't believe is on our sheet anywhere. This is when we're going from repeated addition to multiplication. That really is what we call the definition of multiplication. Should we throw that on a reason bank, you think? It isn't something that shows up so very often, but it might not be a bad idea. Maybe on, I'm trying to think where we have room. Do you have room on the bottom here somewhere?
Other side.
On the other side? Yes, sir. Somewhere on here, let's do a quick example of what the definition of multiplication is. I would maybe just write down that definition is repeated addition. Maybe a little example for real simple terms. X plus X plus X equals what? 3X. And my reason would be definition of multiplication. It's not a property that you're going to see a ton of times, but it might not be a bad idea to put it on that reason bank because it is something that will show up from time to time. What's that? Don't let them in? That's good. Okay.
Yeah, we're leaving.
So now we can finish up that last proof then, because MD now is equal to, what's MB plus MB? 2MB. And the reason is, what did we just talk about? Definition of multiplication. Okay. I think what we've done today, I'm hoping it's kind of taken out some of the scariness a little-ish. A little bit? Smidge? Let's see here. Let's try this.
Blood described. Wait, what is it? What?
We're not doing all of this at all, so let me show you guys. So on this one here, I'm going to kind of work, I'd like to kind of work through these few proofs here over the course of the next few days. What I'd like you guys to do, I apologize that I didn't really do a good job. I forgot to number them. So I'd like you guys to start with the algebra proof on the first page. I want you to do that first one. So we'll have algebra proof for tonight. On the second page, I'd like to do the proof on the bottom. It's the segment one. We have bottom of the page. The first one is the algebra proof. The second one is the segment proof. And then
That's it.
let's try the angle one on the bottom of the third page. We'll just do 3 of them. So it's basically we're doing the algebra proof. So it's page 1, bottom. Page 2, bottom. Trying to make this easy on you. Page 3, bottom. Okay. When you do those three things, sir. When you're doing those three guys, make sure you have your reason bank and your progression sheets there. Okay? They should mirror out exactly what we worked through in class. Yes, sir.
I don't know.
Oh, all right. And we'll continue working through these tomorrow.
Oh, gee.